landforms of the earth. Since there is a lot of heat in the interior of the earth, and rocks are not good conductors of heat, they are bad conductors of heat. Now, the internal heat of the earth, it melts the rocks within the earth's surface, and it keeps the asthenosphere underneath the crust in a completely semi-molten state. Now, this kind of a condition, it leads to several landform development on the surface of the earth. Now, there are causes in the form of plate tectonics, upliftment and submersions of land. There are sudden forces like earthquakes, volcanoes. There are exogenic forces which operate on the surface of the earth. They are not within the surface, they are on the surface of the earth. Now, all of them are definitely the reasons for formation of various landforms. So, a simple understanding is that a landform is a natural feature of the surface of the earth or on the earth's surface. Huge amount of or a large number of landforms can be correlated on the surface of the earth, and there are many methods to classify it also. Now, what we would be trying to understand for the purposes of geography through maps, the major landforms, major islands and water features map of the world, what we would be doing is we would be classifying and understanding 4 major landforms, and the most important understanding would begin with mountains, followed by plateaus, plains, valleys and basins. Now, mountains to begin with. They are very steep land or hills that have risings. They rise above the land around them, surrounding them, to certain heights, especially drastic and witnessable heights. As compared to other areas surrounding them, they are at a higher height. Now, mountains are of 3 types in a major context: fold mountains, block mountains, volcanic mountains. Now, fold mountains, the best examples, the way fold mountains are formed is due to large scale earth movements, generally because of the stresses in the earth's crust. Now, the most important understanding here is these stresses, they are basically good enough to compress they are compressive forces to compress the rocks. Now, they produce wrinkles, and there are lines of weakness, and ultimately there are mountains. They make fold mountains. Now, we'll refer the data in accordance with the continents and just earmark the folds here. So, to begin with, South American continent, the Andes; North American continent, the Rockies; Europe, the Alps; Africa, the Atlas Mountains; Asia, the Himalayas; Zagros, Albergs, Kunluns. Now, there are many such mountain chains within the sea surface also. Amongst this, the Alps, the Himalayas, they are also the references of fold mountains which are covered by snow. Most important characteristics of these mountains is they have a fold like, a fold kind of a rock strata. They look like arch. They are continuous. They like wave-like formations. They have the reference of anticlines, the crust, and synclines or the troughs. So, crust and trough kind of references due to those arch-shaped formations. Now, the fold mountains that have a existence beneath the sea levels within the sea, generally revealed as part of islands. For example, West Indies. They have the surfaces of those fold mountains. That is what are the islands here. Now, there are oceanic trenches within. Now, there are combinations of volcanic mountains and fold mountains. Now, the best example would be the Mid-Atlantic Ridge that rises, on the floors of Atlantic Ocean and is joined by Indian Ocean Ridge. Further, block mountains, generally referred as the eperogenic forces, the faulting forces, the forces that cause fault lead to formation of block mountains, generally referred to tensional forces, whereas the fold mountains were stress related. Here they are tensional forces. They have these cracks or faults that open up on the surface of the earth or on the crust of the earth, and that is how the submergence occurs, or the land between those cracks, it subsides and there is a rift valley being formed, and then ultimately a horst or a block rises there, a horst or a block mountain stands to be created. So in general, block mountains have flattened surface. They are referred as horst mountains. Generally, these block mountains, they are separated by basins, intervening basins. They are called as grabens. If there are two parallel faults, the valley floor, it will sink and there is a rift being formed, that is called as rift valley. Now we have a good set of examples here. The extensive rifts of African Rift Valley, the Vosges of France, Black Forest Mountains in Europe, Sierra Nevada Mountains of California, all of them are part of these block mountains. Volcanic mountains. Now, they are generally built from the material ejected from the volcanic eruptions, from the fissures in the Earth's crust. In general, they are very diverse. There are very great differences in volcanic different eruptions, as well as there are differences in the material that they throw up. So there are very diverse volcanic mountains on the surface that we find, and the shapes that they take, the cone shape, the shield type of volcanic structures, all the references of the circum-Pacific belt, the volcanic peaks there, all of them are different. Now, fissure eruptions, generally they build plateaus, and now the references of certain mountains that we are going to list around. Now, Mauna Loa in Hawaii. Now, this is a very huge mountain rise from the ocean floor itself. Now, in the circum-Pacific belt, Mount Fuji from Japan, Mount Mayon, Philippines, Mount Merapi, Sumatra, Mount Agong, Bali, Mount Cotopaxi, Ecuador. Now, all of them are part of variations, great differences that we see as part of volcanic mountains.